Your energy center is a core aspect of your hydronic system. Designing your production units may be very dependent on the scope of your project, and it can be that your most optimal solution is a hybrid production system, in which you combine two different production units at the same time, for example, a heat pump and a boiler. But how are you going to design your energy center? You start from your secondary circuit, where you first define your design flows. Next, you have to make a decision about the configuration of your production center. How are you going to connect your heat pump and your boiler? Are you using a serial connection, a parallel connection, or a shunt connection? Only once you have defined this, you can start dividing your design flows of your secondary circuit over your boiler and your heat pump. For example, if we choose for a serial configuration, then we know that we can divide our design powers over our production units, while our design flow rate will remain constant throughout the system. Finally, you can start to design your production units and finalize your hydronic system. But will this system perform optimally? How can you validate that your energy center will behave in the way you expect it to behave? With the Hysopt software, we can simulate the behavior of our system. Let's look at an example. We have a design flow of 100 kilowatts entering the energy center at a temperature regime of 60-40 degrees. We now create a hybrid connection between a heat pump and a gas boiler. The heat pump can only provide heat at 50 degrees. Therefore, we choose a serial design in which the heat pump first heats the flow up to 50 degrees and the gas boiler further heats the flow up to 60 degrees. As both production units increase the flow by delta T of 10, we expect both units to contribute equally to the heat production of the system. However, when simulating the model, the Hysopt software indicates that the heat pump only contributes for less than 30%. This is because of the poor design of the secondary system. Due to the constant flow, the return temperature increases in partial load. When the return temperature is higher than 50 degrees, our heat pump can no longer contribute to the heat production, and the boiler therefore has to increase its production share. When comparing the heat contribution of both production units over a simulated period of 1 year, we can conclude that the heat pump contributes less than what we expected during the design of our energy center. If we want to optimize the system performance, we can now replace the heat pump by a high temperature heat pump that can provide 60 degrees and re-simulate the model to see whether the heat pump's contribution share has improved. This way, with the Hysopt software, we can quickly determine the most optimal configuration of our energy center. What do you think? Did you experience any problems with your hybrid production design before? Let us know, and let us tackle those problems together.